Chapter 15, Water Resources, third of 30 lectures. Let's start out talking about a realistic possibility, but an expensive possibility, and that's desalination. Currently, Florida is desalinating, the Middle East is desalinating. I know California is looking to start desalination too. So, of course, 71% of the planet is salt water. Why don't we take some of that salt water and convert it to fresh water? The problem is it's really expensive. One of the reasons the Middle East relies on this is because not only do they not have much water, but they got lots of bucks. The problem is it results in a very salty brine that must be disposed of without harming aquatic or terrestrial ecosystems. You can't just throw it back into the ocean because salinity. So what they do is remove dissolved salts in the water. It evaporates the water. It leaves salts behind. You could use reverse osmosis. You might have a reverse osmosis system in your house where water is sent through a microfilter, and what happens is it removes all the heavy stuff like leads and salts. Right now there's about 15,000 of these plants in 55 nations. The problem, again, high cost, very high energy footprint. It does keep down the algal growth and kills many marine organisms too. So we're knocking out that primary productivity if it goes back into the ocean and kills the animals. And of course we get lots of brine, salty. So how about just using fresh water a little bit more sustainably? We can cut water waste. Instead of taking that 15-minute shower, maybe a 3 to 4 minute shower. Maybe raise water prices. If you raise water prices, the idea is that people will use less. Slow population growth, of course, more population goes up. The more we drink, the more food that needs to be grown. We can protect our aquifers, forests, and other ecosystems that store and release fresh water. One thing we'll talk about later is the more we cut down vegetation. 1/2 to 2/3 of water is wasted. The cost of water really to users is low, particularly in the United States, and a lot of that is because it's subsidized. Raising prices will hurt lower income farmers and city dwellers. We don't want to do that. We don't want to isolate them. So maybe we establish lifelong. Now, let's improve efficiency in irrigation. Since we know about 70% of our water goes to agriculture, let's figure out how we can do it better. Maybe we can use a center pivot system with low pressure sprinkler. I'll show you an example of this in a second. Precision application sprinklers. The best thing to do is use drip or trickle irrigation or micro irrigation. It is costly, but it uses a lot less water. It wastes much less water rather. This is an example of those three. A center pivot system is the example on the right side right here. And what the center pivot system does is it actually is kind of a big sprinkler system where there's a pump in the middle that pumps water up, and then of course it waters the plants. The problem is a lot of times 50 to even 90% of that water doesn't even reach a plant because it evaporates. So maybe we could lower that boom a little bit and get it a little bit closer to the plants so it doesn't lose via evaporation. One thing that's used is gravity flow. Gravity flow is not very good, so this would be slanted downhill. What we do is flood fields like this. Cranberry fields are kind of like this. It's about 60 to 80% efficient with these things called surge valves. However, as you can imagine, the wider these are, the more surface area, the more evaporation. It does hit its intended target, though. The best thing to do is drip irrigation. So these are pipes right here, or plastic. You can actually use these at home around your flowers. And what happens is these plastic hoses or pipes actually have holes in them. And what you do is you send the water out and it goes in there and it directly hits the roots. This really eliminates evaporation and really eliminates waste. So reducing irrigation water losses, avoid growing thirsty crops in dry areas, import water-intensive crops and meat from other areas, but reality is this is a global issue. Encourage organic farming, polyculture to retain soil moisture. Monitor soil moisture when necessary. Don't overwater. Don't overwater to the extent of waterlogging or salinization. Use drip irrigation. Irrigate at night. A lot of people water their lawns. I see these sprinklers on during the middle of the day when it's really hot. It's actually really bad. It can actually burn out your grass because that little water molecule on your grass actually acts as a magnifier. Line canals that bring water to irrigate ditches and irrigate with treated wastewater, something called gray water. You do a half a flush on your toilet when you go number one, and what happens is that goes to your flowers or even your yard and waters it. Remember, the best is early morning. That's when golf courses do, because then you have all day for that to be absorbed in the roots and to not sit and rot your plants like at night. So poor farmers, they do conserve water using low-tech methods. There's human-powered treadle pumps, which we'll see in a second. That's a little bit more third world country. Haven't seen those around the United States too much. Harvest and store rainwater. You can actually get rain barrels through the county or through the state and hook those up to your gutters, and when it rains out, you store that water in there. Use something called tensiometers, which measures soil moisture, so don't water if it's already moist. A lot of farmers do make that mistake. Use polyculture to create canopy vegetation, so there's vegetation that goes over other vegetation and reduces evaporation or loss by other plants. This is an example of the pump like that, where it's pumping water up out of the ground, and of course you're getting good exercise as you're doing it too, not wasting much there at all. We can cut freshwater losses in industry, so think about big industry. Recycle water in industry, that's oftentimes not used. What happens is, like in nuclear power plants, water comes in to cool machines, or in big industry, and then it goes right back as thermal pollution, which is very bad on our environment. We can fix leaks in the plumbing system. How many of you have drips coming out of your faucets at home? Xeriscaping, I'll show you a picture of that. That's very common in the great southwest part of the United States. Gray water is what I talked about before, a half flush on the toilet. Maybe pay-as-you-go water use amount. So avoid, again, thirsty crops, import water-intensive crops and meats. We talked about this before. Ways of getting rid of this waste. Line canals that bring water into irrigation and ditches. Maybe put a little plastic down so we don't get lateral recharge where we don't want it. This is something called xeriscaping. If you go out west, and it can be even more extreme in this, in desert communities like Phoenix, they don't grow grass there. If they have grass, it's very tiny because it's so water intensive and the sun is so hot out there in the summertime, it just dies anyway. So use what's natural to the area. Xeriscaping uses lots of rocks, lots of cactus and things like that. We don't use crops or plants in this area. So how can you use less water to remove waste? Use human sewage to create nutrient-rich sludge to apply to croplands. A lot of the waste from septic systems around this region actually go out to farmers' fields and use that to fertilize. That's a very organic kind of method. And of course, in Milwaukee, the Jones Island produces Milorganite, which is a very popular fertilizer that uses human feces. Use waterless composting toilets too, so they actually compost the feces. This can be used a little bit better in warm areas where it dries out quickly, so it goes outside, dries, and you don't waste that, because literally when you flush the toilet, that's all fresh water that goes down. We've got to protect our water supplies. We need to apply strategies at local, regional, national, and international levels. We need to apply strategies at a personal level too, again, not run the water as much when you're brushing your teeth kind of thing. Use water-saving toilets. Bet you most of you have that. Shower heads and faucets. Short showers instead of baths. Turn off the sink and faucets while brushing teeth, shaving, or washing. Wash only full loads of clothes, or use the lowest possible water level setting for smaller loads. Repair water leaks. Wash your car from a bucket of soapy water. Use gray water, so water that's not totally tainted from your toilet. And use the hose for rinsing only. Don't leave the hose on the whole time while you're washing your car. If you use a commercial car wash, try to find one that recycles its water. That's hard to find. Replace your lawn with native plants that need little if any watering, so grow things that are natural around this region. Water lawns and gardens only in the early morning or in the evening, and use gray water. Use drip irrigation and mulch for gardens and a lot less water. We can lessen the threat of flooding. Of course, flooding is a huge issue too if we would just leave our wetlands alone, our natural vegetation and watersheds. Let's not build in areas subject to frequent flooding too, and let's leave general alone. Of course, we like living on floodplains, very high productive areas, wetlands in particular, lots of silt, lots of fertile area. They provide natural flood and erosion control, and they maintain very high water quality and we recharge groundwater in these floodplains, wetlands area. The benefits, as I said, very fertile soils by rivers for use and recreation, very flat land for urbanizing, easy for transportation too. We do make floods worse though. Levees are a huge problem. Levees, like in New Orleans, of course, levees are what keep Lake Pontchartrain, and the Mississippi River intact, while it makes the water also go faster. So if we have something like a hurricane, like when Hurricane Katrina came in, it caused it to flood. Paving and development increases runoff. So the more we pave, the more the water just runs off and will flood areas instead of being absorbed by vegetation. We need to remove remove water absorbing vegetation, which is bad. We drain wetlands and build on them. And of course, rising sea levels from global warming means more. This is just a little case study in Bangladesh at one time. And of course, the people out there have cut down lots of trees. And what happens is when you cut down lots of trees, as you can see in the picture on the right, the water just rushes right down the hill and takes all the sediment with it. So not only do you have great erosion, but you can't even farm that area anymore. And so Bangladesh, dense population on a coastal floodplain region, very moderate flood, maintains fertile soil, increased frequency of large floods because they've removed all that vegetation and destroyed the coastal wetlands. Mangrove swamps have been cleared. That's what would catch a lot of these floods before it gets into the pollutants and actually take out many of the toxins before it gets into the oceans. Increased damages from storms too, because swamps to protect. We need to rely more on nature systems, on wetlands, natural vegetation. We need to rely less on engineering devices. In other words, as I've said many, many times before, just let nature do as it does and let's not interfere too much. Take away dams, levees, and channel. They are no good for us. Preserve forests on watersheds. We need to preserve and restore wetlands and floodplains. Tax development on floodplains. So if you're going to build on a floodplain, you're probably going to pay a little bit more anyway in insurance because you're prone to become flooded. Increase use of floodplains for like agriculture and forestry instead of cities, like the city of Milwaukee. We should be farming there because it's excellent and fertile land because of the silt buildup. Control, we got to straighten and deepen streams channelization. We really shouldn't be doing that. We shouldn't build the levees, shouldn't build the dams like that because that silt, of course, builds up back there and to fertilize. So the major ideas, major goal or global environmental problems is growing shortage of fresh water in many parts of the world. We can expand water supplies in water-short areas, but the most important thing to do is reduce overall water use and use it much more. We can use water more sustainably. Of course, we can cut water losses, raise water prices, and protect aquifers, forests, and other ecosystems, and bring that water back. Of course, large dams and diversion projects, they're there for electricity, they're there to divert water for food, drinking water, flood control, but they can definitely degrade the aquatic natural capital. So we really need to rely more on things like solar energy when we're doing especially things like desalination. Solar energy can get quite warm and we can use it quite well in order to cause evaporation. And of course we need to recycle water more too. So that's it for chapter 15.